Assalamu alaikum. I have know your voice. Do you have my voice? But I have know your voice, Professor. Yes, I have your voice. Are you okay? Thank you, Professor Bala. Thank you. Yes, but just three persons are participate. Of course. Very good, very good. Okay, very good. Both of them are possible, in fact. Assalamu alaikum. Hello, Professor Arshad Umar.
Walaikum Assalam. How are you, sir?
Thank you so much. Thank you. Happy New Year, Ramazan.
Same to you. Thank you, and same to you. So you are. I
Thank you.
think the Ramadan must have started today. From
No, in Iran is tomorrow,
tomorrow.
the
Acha.
first day.
Oh, okay, okay. Tomorrow is also for us. Tomorrow is the first day. Inshallah, we will
Very
fasting
good.
from tomorrow.
Inshallah.
Walaikum Assalam. Walaikum Assalam. Yes. Walaikum Assalam. How are you, sir?
Thank you so much. Thank you. Happy New Year.
Same to you. Thank you, and same to you. So you are. I think the Ramadan must have started today. From
No, in Iran is tomorrow,
tomorrow.
the
Acha.
first day.
Oh, okay, okay. Tomorrow is also for us. Tomorrow is the first day. And we will
Very
fasting from
good.
tomorrow.
Inshallah.
Okay, Professor. Am I audible to you? Am I audible to everyone?
Yes.
Okay. So I think we have a few minutes more, then we can start the webinar. We are good to go then. Am I audible to you?
ये इसे को इको हो रही है.
Am I audible to everyone?
Yes.
I think we have a few minutes more, then we can start the webinar. We are good. धर्मी आपका माइक ऑफ है? Am I audible to you?
ये इसे को इको हो रही है.
Am I audible to everyone?
Yes. ये
धर्मी आप लीव कर दीजिए मेरे को. आप चाहें तो लीव कर दीजिए. नहीं तो लीव कर जाइए आप. लीव कर सकते हैं. इसलिए हो रही है इको क्योंकि वो मैं समझ गया. Mr. Asif, am I still audible to you?
Yeah, you are.
I think now
Your,
the
au-
echo.
your
Now
audio
the,
is clear now.
okay, now it won't be echoing.
Assalamu
जी
alaikum,
सर,
everyone.
जी सर. अब अब तो नहीं हो रही ना सर? अब नहीं हो रही ना? जी देख लीजिए. तो मैंने हेडफोन लगा लिए सर, अब नहीं होगी.
फिर रिपीट हुआ था अभी तुम्हारा. चलो.
Okay, so I think now we are good to start. Now I think the voice is not echoing, right?
It's okay. It's audible.
Okay,
A little bit echo is there, but it's still audible.
okay. So, respected principal, University Polytechnic, Professor Arshad Umar, in charge Civil Engineering Section, Dr. Mohammad Kafi, eminent speakers, Dr. Behruz Bordan, and dear participants. A very good afternoon to all of you. We start today's session with a few verses from the Holy Quran. I would like to invite Dr. Ahmed Fuzail Hashmi to recite a few verses from the Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يا أيها الذين آمنوا اتقوا الله ولتنظر نفس ما قدمت لغد واتقوا الله إن الله خبير بما تعملون ولا تكونوا كالذين نسوا الله فأنساهم أنفسهم أولئك هم الفاسقون لا يستوي أصحاب النار وأصحاب الجنة أصحاب الجنة هم الفائزون صدق الله العظيم. In the name of Allah, the most gracious and the most merciful. O you who believe, fear Allah, and everybody must consider what he or she has sent ahead for tomorrow, and fear Allah. Surely Allah is fully aware of what you do. Do not be like those who forgot Allah, so He made them forget themselves. those are the sinners. The pupil of the hell and the pupil of paradise are not equal.
In
The
the
pupil of paradise are
most
the
gracious
successful.
and the most
If we had sent down this Quran upon a mountain, you would have seen it humbled and burst apart from the fear of Allah. We cite such examples for the pupils so that they may ponder. He is Allah, beside whom there is no God, the knower of the unseen and the witnessed. He is all merciful and very merciful. Okay, thank you.
Uh, Thank you, Dr. Fuzel. And hello and a very warm welcome to all of you again. Thank you for taking the time to join us today in this webinar. Due to a large number of registrations, we had to change the platform to YouTube Live. I would like to mention that you can have the same privileges as before. We will be having a question and answer session towards the end of this lecture. You are requested to put all your questions in the comment box or send us on the Telegram channel. I would also like to mention that the attendance cum feedback form will be available in the YouTube chat box, and it is mandatory for each participant to fill it up. Now, I would like to introduce today's presenter, Dr. Behrooz Gordan. Dr. Behrooz is working as an assistant professor at the Department of Civil Engineering, Islamic Azad University, Iran. Islamic Azad University is one of the largest comprehensive systems of universities, colleges, and community colleges in the world. Dr. Behrooz Gordan received his PhD in civil engineering at University Technology Malaysia in 2014. His research interests include numerical and seismic analysis in earth structures, slope stability, earth dams, retaining walls, and data analysis using optimization techniques and machine learning. He is an author of over 50 papers published in related journals and international conference proceedings. Dr. Gordan is also the editorial member of 4 international journals and editor-in-chief for the journal Modern Transportation. Dams have made an important and significant contribution in the development of human beings and society. The benefits derived from dams are always considered in the field of renewable energy and agriculture and are very important to control floods. Earthen dams are preferred over concrete gravity dams due to their simple construction and relative economical advantage. Locally available materials and less skilled labor reduce the construction cost, thus it is still widely used. Despite significant development in geotechnical engineering, earthquake continues to cause the failure of many dams and result in the destruction of life and damage of properties. So the stability of earthen dams during earthquakes is of primary concern. In this lecture, you will learn how to perform the dynamic analysis of earthen dams, and then we have got for you a totally free question and answer session at the end of this lecture. It is going to be a very interesting lecture, so stay tuned and to learn more about it. At this stage, if someone has any questions, please put it up in the comment box. I would like to mention again that you are requested to put all your questions in the YouTube comment box or send us on the Telegram channel. And also remember that the attendance cum feedback form will be available in the YouTube chat box, and it is mandatory for each participant to fill it up. With this, I would now like to invite Professor Arshad Umar, Principal, University Polytechnic, for the inaugural of the session. Professor.
Thank you, Mr. Bilal. First of all, I will request all the participants to put off their mics. Please put off your mics. There is echo. In charge of the section, Dr. Muhammad Kafi. Resource person, Dr. Behrouz Gurdan. Webinar coordinators, Mr. Muhammad Danish, Mr. Muhammad Shahir Ali,
First of all, I would request
and
all
Mr.
the
Muhammad Bilal.
participants to put off their mic.
Moderator, Mr. Muhammad Asif.
Switch off your mic.
Faculty members, and my dear participants. Assalamu alaikum and a very good afternoon to you all. On behalf of University Polytechnic, it is my pleasure to welcome all the participants from all over the world for attending the webinar on dynamic analysis of earthen dams. I also welcome the eminent speaker, Dr. Behrouz Gurdan, who will be sharing his knowledge and vast experience with the participants. I will give you a brief history of University Polytechnic. University Polytechnic was established way back in 1937. Initially, 3 diploma engineering courses were offered. They were diploma in civil engineering, mechanical engineering, and electrical engineering. Right now, we are offering 9 diploma in engineering programs and 1 advanced diploma in food technology. We have 78 very well qualified faculty members. In the current session, we have organized 1 international conference, 3 faculty development programs of 1 week duration, and a large number of webinars. In fact, this is the second webinar we are organizing today. The objective of this webinar is to introduce
Hello, sir.
participants about the analysis of the earthen dams.
Hello.
Earth dams and embankments play an important role in irrigation, flood control, and development of railroad infrastructure. Considering their functional requirement and importance in serving the community, it becomes imperative that they remain operational even after a strong motion earthquake with minimum damage. The frequent occurrence of destructive earthquakes in the past in various places, causing loss of thousands of lives and damage to dams and earth structures, has demonstrated the need for earthquake resistant design of these structures. An earth and rockfill dam is considered to be a desirable type of dam in seismic regions due to its flexibility. Nevertheless, its design needs numerous considerations due to complex stress-strain characteristics of soil and rock, which is generally not applicable for other types of dam. Hence, the precise study of the response of earth dams to earthquakes is one of the most complex issues in the field of soil structures. I'm sure this webinar will be useful for faculty members, research scholars, and people from the industry. I hope all the participants will find this webinar beneficial for enhancing their knowledge and find it an enjoyable and memorable event. In the end, I extend my best wishes and support to the organizing team for conducting this webinar and make it a successful event. Thank you, goodbye, and all the best.
Thank you, Professor. Now I would like to invite our speaker, Dr. Behruz Gordan, for the lecture. Dr. Behruz.
Okay. Hello, everyone. Do you have my voice?
Yes, Professor.
بسم الله الرحمن الرحيم إنا أتيناك الكوثر فصل لربك وانحر إن شانك هو الأبتر. Thank you so much. Firstly, Professor Arshad Umar and all your co-workers in your faculty and civil engineering department of Aligarh University Polytechnic to create and make this opportunity to share knowledge with this webinar. I am Behruz Gordan from Iran, and as you know, I am assistant professor in Islamic Azad University. So my topic is dynamic analysis in earthen dam. I am going to present it with my PowerPoint. Okay, do you have my PowerPoint now? Very good. Dynamic analysis earthen dam. So, firstly, as I mentioned, you a little bit introducing myself. As I mentioned you, I am assistant professor Islamic Azad University Iran Tehran branch, and I am a member of Iranian Committee on Large Dam. Also, I am member of Engineering, Seismology, and Earthquake Engineering Research Group, ECR, University Technology Malaysia under my supervisor, Professor Aznan bin Adnan, as I got the PhD during the 2010 to 2014. First of all, I want to focus on the introduction of earthquake because I'm sure that there are so many students, undergraduate students, and needs to collect a little bit information about earthquake because the dynamic analysis exactly related to earthquake. The main force is earthquake, in fact. So in this section, I have a lot of slides, but I must go and finish this webinar just on time. So I will go very soon and show you and explain when I think that I must explain more, I will do. And when I think that it's not necessary and students can get the PowerPoint and study at next, I will go very soon. Anyways, Earth structures. There are some similarity between Earth and egg. Earth is considered of some layers. As you see in this slide, this is Earth. There are some layers such as crust, upper mantle, lower mantle, outer core, inner core. So there is a movie, but we have not time to share. But I share this PowerPoint and you can this movie and click on it at next. As you see in this slide, so the core is the middle, after that outer core and lower mantle and upper mantle. So crust is after upper mantle. Please focus on the radius of Earth. 6,346 kilometers is Earth's radius. And in this slide, you can see the layers of the Earth with materials. As you see, inner core is solid and outer core is liquid, mantle, and after that crust. Crust is between 0 surface to 100 kilometer in terms of thickness. And you can see other kilometers such as solid, liquid, and for example, 5,100 kilometers is solid and 2,900 kilometers liquid. Anyways, so this is the basic information. In this slide, how can moving lithosphere plates under lava? So simple. As you see, this is a flow under the lithosphere plates. And there is two flow, in fact, right side and left side, both of them in one time. And when we have this situation, so lithosphere plates can tension. In this slide, this is the tectonic plates of the world. As you see, in the left side, you can see the American and Africa at present, but 200 million years ago, both of them are face to face. And moving plates is the case of Earth change. You see the left side up million years ago. All of the continent are together. After 135 million years ago, a little bit change. After 65 million years ago, right side, same to present. And today is the Earth, as you see. But what's happened next 100 million years? Definitely again change because of moving plates. So Earth can change. Boundary of tectonic plates and moving directions. You see, there are some plates of the world in this slide. As you see, for example, Arabian plates pressure on Iranian plates always. It means that the lung of Iran, the lung of Iran can under pressure and smaller and smaller with time. What about the white? It's under tension pressure, tension force. So a little bit larger and larger with time. What does this mean? It's tectonic plates moving, in fact. So if you focus on Indian plates, so it's under pressure. Background of earthquake in the world, 1980, 1990. As you see in this slide, there are main earthquakes in the world during this time, 110 years, 1980 to 1990. The Ring of Fire is the main ring of earthquake around the Pacific. Also, we have Atlantic and Alpine. Most of the main earthquakes and main shocks in the world is around the Ring of Fire, near to the Japan, Canada, America, and Indonesia. Also, there are some tsunami inside the Ring of Fire. As you see, sometimes we have in Japan or Chile. Important earthquake belts. More than 90% of the main earthquakes is around the Ring of Fire. The review of tectonic plates and moving directions. In this slide, you can see two flows. The behind of the photo, you can see hot rock rises and two flow, and the behind of the under of the ocean, you can see can make an earthquake and tsunami. In this slide, you can see direction of Arabian plates towards Iran plates, as I mentioned you previously, under pressure. Also, you can see Indian plate, same as Arabian plate, both of them under pressure. As I mentioned you, Indian and Iran are same behavior for tectonic plates. But you see Turkish plates is under tension. It's actual. When you have pressure, definitely you must have to tension in order to balance. Type of boundaries: divergent, extensional behavior, convergent, compressional behavior, and transform shear behavior. As you see in this slide, left side is divergent and right side is convergent. And after that, transform is possible to see under shear behavior. There are a lot of movies, but we have not time because more than 168, I think, slides are possible to present in this time. So I can share this PowerPoint and you can see all of the movies at your home and your university. Shallow earthquake. As you see, tectonic forces are under tension, and normal faulting you can see in this slide, and transform fault in the ocean. Shallow earthquakes. Tension and normal faulting at divergent boundaries, streak sleep at transform faults for lithosphere and other layers. subduction earthquake. As you see in this slide, ocean trench convergence and ocean and continent under pressure, and you can see the flow inside the lithosphere and making rising magma for continent. And what about transfer fault? Please look at the left side, the behind. You can see the farm, but if you see my mouse, this is the line, transverse line here. What is this? This is fault, transform fault. Please see the up photo. Sorry. Yes. You can see the fracture zone here, and crest under tension, and transform fault here in this distance. And you can see in this slide, right side below, divergent boundary with blue color and transform boundary with green color. After the introduction of earthquake as required for dynamic analysis, in fact, what is the earthquake? It should teach one course, I think, engineering earthquake. So we have in Iran more than 80 sessions in each semester. But I want to focus on objective. Objective is damage on dam, problem statement, and how we can avoid of the cracks in the earthen. You see in this slide, earthen with road on the crest. This is an example. So earthen can have a road on the crest. In this slide, you can see Bakun Dam in Malaysia as it's a concrete face rockfill dam, and it's the second highest in this type of dams in the world by 302 meters elevation. It's in Sarawak in Malaysia. And in this area, we have also peak ground acceleration, and it's under my study as I got it on 2012. There are some photos about the failure of earth dams and some cracks as you see at next slides. What's happened? All of cities after them must to have safety. So a study about dynamic settlement is important. Also, after the earthquake, it's possible dam was ruined. What's happened? You can see the San Fernando Dam in United States at the left side. Its failure after the earthquake. You see, this is one example about dynamic analysis, and I use in this study ANSYS software. You can use ANSYS in terms of finite element. You can use ANSYS Abacus, and in terms of finite difference, you can use FLAC program also to analyze dynamic analysis of earthen. So you see the part of models such as foundation as moved by earthquake in this line, And you can see the parts of foundations behind the water, behind the saturated dam here. And you can see core clay and shell, upstream and downstream, and you can see the crest in this model. So I use this parameter, as you see, and analysis by ANSYS software. So I used the record displacement time for ANSYS. When I used the ANSYS 2014 and 2012, I used displacement time, but with new version, you can use acceleration time, velocity time, or displacement time. I used version 10. Yeah, this time is version 2021 possible. One more thing I want to share you is that during the modeling, you must, as you see in this photo, if you see my mouse, there are some key points to make a model. 1, 2 at the crest, 3 up of the core, the middle, 4 middle of the core, and 5 middle of the foundation. This is the hot line, in fact. During the dynamic analysis, displacement and acceleration at the crest is maximum, always. And shear stress and shear strain behavior is so important to analysis for point 3, 4, 5, and other points. But I focus on 3, 4, 5, 1, 2 because of maximum value. I use the Nagan earthquake as related to the Nagan earthquake of Iran for vertical direction, and time is horizontal direction. As you see, this is the record of Nagan. You see 5 seconds, 0.02 in terms of time, and you see the displacement maximum 50 centimeter. So the peak ground acceleration for Nagan was 0.65 G. It's a strong earthquake. In other slide, you can see the cracks at the crest in Gujarat of India after 2001 earthquake. You can see a lot of long cracks at the crest. Also, observation of performance of dam during the 2030 Grasmere earthquake. As you see, upstream and downstream, exactly in this area, and at the crest, you can see a lot of cracks, long cracks. Also, observation cracks. Next slide. And you can see the various damages during the heat water on the upstream, because this is dynamic pressure and it's not a static pressure. When you focus on dynamic analysis, dynamic pressure of water is so important to heat upstream. And you can see here Tapper Dam displayed longitudinal cracks at its upstream to during the Bhuj earthquake in India. Lateral spreading zone at the downstream to of the Kaswati Dam. And here, excuse me, do you have my voice? All right, because I was worried. There is nothing. Anyways, I will go on. And you can see the concrete slab dislocation, the Pingpu Dam during Wanchun earthquake in China. This is one of the concrete face rockfill dam. After this earthquake, you can see the long cracks at the slopes. And you see the settlement exactly at the middle of the crest in Zipingpu CFRD as reported by Zipping on 2008. Do you see my mouse, Professor Bilal?
Yes.
Okay, because as you see, this is the middle of the crest, and the settlement is maximum in this area exactly. And you can see also crack at the downstream side of the dam crest, and some cracks also. And in this slide, you can see lower San Fernando Dam after earthquake, as reported by Carl, 1971, after earthquake failure. So what's happened? What should we do? There are some options to select. Just wait and go on. We can explain step by step. So in Los Angeles Dam, also concrete face rockfill dam, after Northridge earthquake 1994 reported by Robert, there are some cracks. A crack at other reservoir dam, as you see, it caused by Monday's 7.9 magnitude earthquake in Anxian County in China, exactly at the crest. Why? Because displacement at the crest is maximum and shear stress of soil is zero. Shear stress in earth dam is maximum in the base based on the soil dynamic, the soil mechanic knowledge. Shear stress make important role on dam behavior during the earthquake. So when you have the minimum shear stress at the crest, it's natural to have cracks and maximum displacement. As you see in this slide, the cracks is widely, and after that, it's so hard to process to repair. For repair, I will explain at next how. Anyways, investigation and evaluate of site geological and geotechnical condition is one of the important aspects of the dam safety evaluation. For this investigation, we must focus on two branches: seismological. Geologists and seismologists works about time history and geotechnical engineering, also about material property and what is the damping in layers, site response, and other. Unfortunately, I have no my. Yes, I have. The investigation and site characterization should be thoroughly evaluated to establish the nature, extent, and in situ geotechnical properties of the material in foundation, embankment, or dam being investigated. So it means that seismological and geotechnical engineering should be worked together to collect data and analysis. In next slide, you can see the earth dam. You can see the left side, the hydrostatic pressure on dam, and also how you can use the dynamic pressure on dam with different methods. The distribution of loads is possible in this slide. Anyways, hydrodynamic effects to include the earthquake-related hydrodynamic effects in stability analysis of water retaining dams, the hydrodynamic threshold, delta pH, delta PhD, below reservoir water level may be estimated from the following Zanger. 1952, you can see the formulate and you can see the charts, Y over H and pressure coefficient as you need to see to make a delta PhD. The hydrodynamic pressure may be directed inward or outward of the upstream dam face. The outward direction being critical for stability should be considered always. In this slide, you can see the time history analysis of Bakun Dam. As I mentioned you, it's in the east of Malaysia, Sarawak. You see the right side, there are two maps. First one is peak ground acceleration or PGA map for 500 years in Malaysia. It was related for my supervisor, Professor Azlan bin Adnan, because he was earthquake engineer. And also he made on 2008 peak ground acceleration map for 2,500 years. So you have three color, green, red, and blue here, and red and blue here, with different PGA. This is the Bakun Dam in the middle, and this is the meshing of concrete face rockfill dam. This is aggregate rockfill, and the face is concrete, and this one is water. So when you want to model this type of dam, you must be careful about interface between the rockfill dams, rockfill material and concrete, and between the concrete and water. You need to make interaction effects. So it's possible by ANSYS, and you see the boundary condition as used for this model, and you can see the key points, main points in the dam body, 1, 2, 3 until 9, to collect the data, output data, and consider what's happened for them during an earthquakes. And you can see on left side the main location of dam, in fact, the east of Malaysia. So in this table, we used different material properties as made for this type of dam in terms of material elasticity, yield stress, tangent modulus, Poisson ratio, density, and friction coefficient between materials. Friction coefficients is necessary when you want to make an interaction between different materials in dam. If you focus on dynamic analysis without interaction, it's nothing. You must make an interface between materials by finite element and meshing. As you see in the middle of the photo is the meshing of dam. When you use the finite element, you must use the mesh. The question is, which mesh is the best? Try and error. You must try and error. You must mesh, analyze, and getting the output data. After that, in second step, a little bit smaller mesh and check the output data. If your result in second phase is same as the first phase, no need to small again. It's resolved. If you have difference between both, so you must for third section again small and small. You must make your model small and small in order to get the accurate result. And in this slide, in this side, left side down, you can see different materials as used for dam body. For time history, I used 3 records for this analysis. Figure 9, 10, and 11. You see, for different time and different peak ground acceleration, I used 3 earthquakes. First one is Nagan earthquake. Second is, unfortunately, I have Azna record and Palm Spring record. One of them is near to 500 years PGA map, and another is 2500 PGA map for Malaysia. So I select the record based on the PGA map on Malaysia. So you can see in different key points, you can see horizontal displacement and vertical displacement and shear stress and shear strain in order to consider the behavior of dam during an earthquake. Also, you can use the response spectra analysis for dynamic analysis. What is that? The first one was time history, record. You use the record. But also, the first, one more thing I want to tell you is that the first analysis, time history, is nonlinear analysis, and it's so accurate. But when you focus on response spectra analysis, you must make a spectra. Based on which? Based on the foundation materials of the dam. For this purpose, you must use American Society Civil Engineering acceleration spectrum curve to make the curve, make the spectrum curve, in fact. As you see, the left side, you can see this type of curve, and you must make this curve based on different materials. What type of foundation do you have? Type 1, type 2, type 3, type 4, type 5. A, B, C, D, E. E is the weak foundation and A is the best foundation in terms of resistance. Hard rock, in fact. So you can make these curves by American Society Civil Engineering acceleration spectrum curve and use it for input data to ANSYS or Abacus. When you make a curve, you use it for input data. As you see here, my mouse, please see my mouse. After you you make a model by meshing and use material properties for input data for different section of dam. You must focus to input data, material properties, boundary condition, modeling, and meshing. For this type of analysis, you need to frequency in different mood shapes. What is that? What is frequency? Frequency reverse. Frequency is reverse uh, the period of structure, in fact. What is period? Period is going and back structure, go and back during an earthquake. It means that what time is sufficient for one time go and back during an earthquake. This time is period, and the reverse of period is frequency. So for this type of analysis, response spectrum analysis, you need to frequency. Which frequency? What frequency? How many frequency do you need during this type of analysis? As you see the mesh, there are a lot of nodes here. It means that dam divided to a lot of mass. Each node has a special mass, in fact. Each node, one mass. Second node, second mass. Anyways, so when you have n nodes, in fact, you have n moods for vibration. For modal analysis, it's possible in ANSYS and Abacus also with free vibration analysis to take out the frequency in different moods. For example, when you have more frequency, your analysis is more accurate. When you have frequency in different mood shapes, definitely your response spectrum analysis is more accurate. After free vibration analysis, you must use the combination modes by ANSYS and click on spectrum analysis and get the result. The big question is which type of analysis is more accurate? Time history or response spectral analysis? My point of view, I think time history is the best because of nonlinear behavior. You can input the hysteresis curve of different layers inside the dam during the analysis in terms of input data for soil materials in different sections of dam. You can use the hysteresis curve. What is the hysteresis curve? A stress and a strain in each cyclic load. All of them related to soil dynamic and needs to knowledge about the soil dynamic. I have no time to explain more because I have a lot of slides. Anyways, I want to just share the line, in fact, for dynamic analysis of earth dam, time history is possible, response spectrum analysis is possible, and you can use them and use ANSYS or Abacus for this purpose. Very good slides. Do you have my voice? Sorry, because I worry sometimes. Mr. Balal, do you have my voice?
Yes, Professor, it is available.
All right, thank you so much. Thank you. So in this slide, 3 conditions from Velita Dam. You can see canyon and earth dam. You can see bedrock inside. You see, this is bedrock. because this is in the curve. The behind of the dam also is bedrock, and the mountain in abutment also bedrock. So I put this slide because I want to explain one valuable notes about distribution of acceleration during an earthquake. According to the literature, also I have one paper in this area I can share you. When you have a record in bedrock here or here, both of them are bedrock, or here, there is bedrock also, rock, bedrock. So during the distribution of acceleration, what is the acceleration at the crest? Mostly between 2.8 to 3.2 times is acceleration. For example, if you have 20% of g acceleration on the bedrock, so after side response, acceleration is more at the crest, totally 3 times, between 280 to 320, 3.20. So generally 3 times. As I mentioned, I had this seminar in Iran Komitan Large Dam 5 years ago, I think. We have one Earthen dam. It's the biggest in the Middle East. It's Karkhe in Khuzestan province. So my friends are in this seminar because they are worried about the data of accelerometer. They are worried to check this device, in fact. So after that, I told them based on the literature, your acceleration at the crest should be 3 times rather than the bedrock. When they check, unfortunately, he paid a lot of money to change this device. It's so important for instrumentation of dam. Instrumentation of dam to check dam during the time for short time and long term. Short term and long term, in fact. Both of them are very important and significant factors to see what's happened for them during the time by static loads or dynamic loads. In this slide, you can see dam deformation at the maximum excitation under Kukaili record. As you see, this maximum displacement is 0.3 meter at the crest based on Parish 2009. It's nothing. No, it's high. It's not nothing. It's very high. 30 centimeter maximum deformation. In this slide, you can see mechanism of the pile with geotextile as used in the literature in order to soil improvement for this embankment. You see membranes effect of the geotextile in this area, the bending, and this is the load embankment, and you can see some piles here to connect with the bedrock. should connect it inside the bedrock piles always. Okay, and after that use the geotextile, and you can see arcing effect in dam body. So this soil was soft soil, so use this technique. But as you know, if this distance or this elevation is a little bit small, it's better to remove soil, and compaction on the bedrock is the best way. But with this situation, surely this distance is high, and they couldn't to remove the soil and use this type of improvement soil piles with geotextile. And you see vertical drains on soft soil as used based on the literature for soft soils. You can see vertical drains here in the soft soils, and you can see drainage layer 0.5 to 1 meter here, drainage layer, and after that embankment constructed. Also, you can see cases of the shaking table test as used for small scale modeling by Matsumura 2008. So for a small scaling modeling, you need to have shaking table or centrifuge device. For my PhD at University Technology Malaysia, I used shaking table test for small scale modeling. So at next, a little bit I explained about my method to remove these cracks at the crest and upstream during an earthquake by using the IDL material. What is the IDL? I will explain you next 2 or 3 minutes maybe. Next slides. So shaking table is one way to use for earthen behavior during an earthquake. You must install some strain gauges and transducers and other tools inside the dam body, and connect to data logger to see the result, and after that using the scales for dam analysis. Also, you can see deformation shape of embankment subsoil system at different instance of time by one of the best Iranian professor Namdar 2010. You can see inside initial condition, and after 4 seconds of earthquake, you can see here there is not any dam here. Dam is ruined. Dam is damaged. Generally damaged. Okay, anyways, this is some examples to see you, and you can see primary centrifuge test Wang 2011. Also, I had one supervisor, Professor Dr. Rajiv Kumar from India 2010. Unfortunately, I lose them because his contract was finished at UTM, and after that I worked under Professor Aslan bin Adnan in UTM. I have no any contacts no with him because he's not in Instagram, he's not in LinkedIn, he's not in ResearchGate, and just I have a connection by mailbox, and the last mailbox is 4 years ago. I am so worried about him. So he was very good, very good. He had 2 postdoctorate in Korea, and one of them in Korea and second in United Kingdom, Leeds University, I think. Anyways, he used centrifuge for this type of tests. He was so expert in this area, Rajiv Kumar from India. There are a lot of good professors in India because India is big and in terms of population is more. So you can see Turizo 2010 also used the shaking table, small scale modeling. You can see water here, water inside the model and saturated the model. Here is core, you see, and you can see the network and plexiglass as used for this model. You can see the network, and after the shaking here, after earthquakes, you can see deformation very clear. Then this network may be changed, surely changed, and you can see deformation inside the body after quake. So this model is saturated, and after that earthquake. So I put this slide because I want to explain that when you want to focus on dynamic analysis of Earthen, you must focus on what time earthquake is occurred on the dam, during the construction, after the construction, the first reservoir, and after consolidation. Maybe 20 years after dam is constructed, maybe 20 years after that you have earthquake. What's happened? Definitely your dam is consolidated, and this condition should be put in your model when you want to analyze them during the construction. It's better to focus on slope stability, on drain, on consolidation condition. UU materials is sufficient for your model. Short term, long term. Which one do you have? Based on your option, you must put input data inside the software program. Please be careful about that. And you see some shaking table test here. After the formation, you see the C condition, D condition, A and B. And damage in dam under earthquake is problem statement, and it's possible, damage is possible at upstream, downstream, and crest. Based on the literature review, there are some main notable words as I want to share you. Acceleration is maximum at the crest. Maximum settlement is in the middle of the crest. Interface is very important for analysis. The amplification procedure related to the soil properties is very important. In fact, this is site response effect. And the shape value is affected on dynamic analysis 2D or 3D. So shape value is so important. When you have U shape, it's better to make earth dam because you can use 2D conditions. And when you focus on 2D conditions, it's so simple for your PC to solve the problem by finite element. When you have 3D conditions, take a time. Maybe you must use a huge PC to solve this problem. But when you need to use 3D, when your value shape is V shape, in fact, this is 3D. But when we have V shape, generally we focus to concrete dam, no earth dam. When we have U shape, river is U shape, so it's better to make a earth dam because of economic. Soil is so cheaper than concrete, as you know. So for earth dam, if we have U shape, 2D, and if we have V shape for river, we must use 3D analysis. Data monitoring is the field in this field recorded a few cases. Finite element method and finite difference method are used for numerical analysis. Shaking table and centrifuge are possible for validating. The slope stability is very important for static and dynamic condition. Slope stability, what is that? This is the safety factor, in fact. Slope stability is safety factor for static condition and dynamic condition during an earthquake. What's happened? For this purpose, I suggest you to use GeoStudio because GeoStudio is sufficient for Earthen, especially for seepage and slope stability analysis. I recommend you to use GeoStudio. And when you want to dynamic analysis, I recommend you to use ANSYS or Abacus because you can manage the stress strain behavior of different layers of soils inside the body in terms of hysteresis curve. As you know, hysteresis curve is so important in terms of damping relation, damping or absorb energy during an earthquake. So for quake analysis, please don't use GeoStudio and please use finite element, Abacus, or ANSYS only. Anyways, you see in this slide physical modeling using IDL, isolated damping layer, IDL. It's my thesis, PhD thesis, my innovation in technology Malaysia, 2014, as recorded. So you see in the left side, there are two layers here, 1 and 2, and 1 vetoed this layer. This layer is reinforced laterite soil by IDL, isolated damping layer. This layer is isolated damping layer. Why damping? Because I improve soil by chips tire and microsilica. I use chips tire to improve the damping of soil to absorb more energy. When I use the chips tire, unfortunately, the resistance is reduced. So I use microsilica to increase the resistance. So this formulation is 90% of laterite soil, Malaysian laterite soil, 10% additives, 7% is chips tire mesh 80, and 30%, in fact 3% of all is microsilica, 7% of all is chips tire mesh 80, and 90% is laterite soil. So I use this model in lab soil, and after that use this model by shaking table. 1/6 of the height dam is this layer. When I use 1/6 of this height using IDL, I removed all cracks at the crest and upstream and downstream during an earthquake, strong earthquake, as related to the dominant frequency. What is the strong earthquake? Resonance condition is the strong earthquake. Ladies and gentlemen, resonance earthquake, resonance condition is the strong earthquake. Please be careful about that. Why? Suppose that you have two guitars. Both of them are at same frequency. When you play with one and when you move other near to this one, naturally your voice is double because the second one without playing is work. It means resonance. When the damp frequency based on free vibration analysis, as I mentioned you previously, and the earthquake frequency is same, is the bad situation and a strong earthquake in fact. So in this model, I use the resonance condition and I use the dominant frequency. So I select the record for my shaking table based on the damp frequency as modeled on shaking table. I manage the frequency on shaking table, exactly frequency of shaking, same as the body of them. And I use the ideal after that without any cracks at the crest and upstream and downstream. It means that it was the best way to remove cracks and absorb energy. As you see, this layer is on bedrock. Here is bedrock. After bedrock, ideal, 1/6 of this distance, this elevation, 1/6. After that, embankment, homogen dam, and using on shaking table and test, and it was the best. Also, I used different models. For example, in this slide, you can see all of the body I used ideal, but it was not good in terms of result because I had cracks also again. And as I mentioned, you 1/6 was the best result. You can see in my model, physical modeling by using IDL, you can see I had failure same as San Fernando Dam in the literature at upstream. Also changing network, and you can see cracks, longitude cracks at line C I had. Also transfer cracks and other cracks at the crest. Anyways, after all, I think I have just 30 minutes, maybe 40 minutes. Am I right? To
Yes, yes.
finish. Okay, I must go very soon because I have a lot of. Okay, this time I want to focus on guidelines for seismic design of earth dams and embankment. It's for India, exactly. GSDMA, you can download, and I recommend you to read carefully, step by step. This criteria is one of the best in the world. So you can see general scope. This criteria is related to Gujarat State Disaster Management Authority, August 2005, revised May 2007, and reviewed by ICOL, International Committee on Large Dam. So consist guidelines for earth dam with small to moderate size and embankment according to Indian codes ISO 11223-1985. Before this one, a little bit I want to focus on failure mechanism. Structural failure slopes and crackings is so important. For deformation, before deformation, you have piping, overtopping, And possible damage effects of earthquake on earth dams and embankment include some items such as slope failure because of internal loading and softening of material exchange or liquefaction, fault displacement under the foundation, crest settlement, permanent deformation, sliding failure, and piping and erosion. Note: to avoid of failure should be defensive design measure. Defensive design measure, as you see by red color, I highlighted because I had no time. It's possible you can download and read it carefully. Deformation, overtopping, cracking, filter materials is so important for design. Filter materials, filter layers near vertical chimney drain is very important. And minimize saturation of materials, important. Uh, Wide impervious cores of plastic deformation, well-graded core and uniformly graded filter materials, uh, important. Large slides into this reservoir is important. Stabilization of reservoir rim slopes to provide safety against large slides into the reservoir. Ground improvement or removal and replacement of foundation material, as I mentioned you, to mitigate liquefaction potential is so important. Establishment of slope adjacent to operating facilities to prevent blockage from slide associated with the earthquake and flooring. All of them are important. Also, about site-specific seismic assessment, small and intermediate dams or embankments, and peak horizontal ground acceleration. You can find a lot of good information in this criteria. This slide is repeated. I think I explained it lastly. So, surely investigation of geotechnical engineering investigation should focus on topics including topographic conditions, description of geology, composition and structure of foundation soils from borrow area and bedrock, principal engineering properties of the rock and soils, including grain characteristics, plasticity, compaction, characteristic shear strength, and hydraulic properties. Geotechnical investigation would typically include drilling and sampling in situ testing, SPT and CPT. Also about location, this structure should not construct near the fault. In fact, near the fault. It's so important. You must avoid to construct earthen near the fault. If you want to make, you must improve your soil by different options, as I mentioned you, using geotextile in different layers in order to increase the damping, using ideal, as I mentioned you, using piles with caps to absorb energy and before before transfer to the dam body, in fact. So you can use different if you have, but this criteria tell you that this structure should not construct near the fault. In fact, near field earthquake, when you have epicenter, the main point to release energy of earthquake, this this point have a distance with the surface. This distance, if be less than 15 kilometers, it means near field earthquake. So when you have near field earthquake or near the fault, you must avoid to construct the earth dam. Also about freeboard, there are some good points you can see. it's recommended to provide a freeboard of at least 2% to 3% of dam height, but not less than 2 meters. If there is a potential for occurrence of landslides near the dam abutment within the slope of the reservoir margins, or 1 meter, if there is a negligible landslide potential near the dam abutments, and also other about overtopping you can use. And about liquefaction, it's so important. Liquefaction leads to loss of strength and increase in settlement, moderate to large earthquake, increase of poor pressure water, build up for sandy soil, exactly for sandy soil, and sensitive clay soil also. After that, effective stress leads to be zero, lose of strength, and increase of settlement. In fact, tau is equal to C plus sigma tangent phi, Moore Coulomb formulation in soil mechanics. When you have liquefaction, you have less shear stress. And you can see about liquefaction, there are some slides on embankment. You can, because I have some better slides at next, I prefer to go because I have no time. What about the in-situ ground improvement? As see here, you can use for in-situ ground improvement deep dynamic compaction, vibration compaction, vibration replacement, jet grouting, deep soil mixing, sand drains, blast densification, and sand and gray piles. What about compaction? For cohesionless soils, a relative density of 80% may be used as an alternative indicator of the minimum compaction requirement. It's so important. Totally, when you have very good compaction, accurate compaction, during the moderate earthquake, I think moderate, not strong, moderate earthquake, when you have a good compaction, I think you have not any problem during an earthquake, moderate earthquake, and small earthquake. But about resonance condition, definitely in moderate PGA and small PGA, but with same frequency, both earthquake and dam, definitely you have problem. As I mentioned, your resonance condition is very strong in dam analysis during an earthquake. Anyways, so seismic slope stability assessment. You can see cyclic stress induced by earthquake shaking, the cyclic stress strain behavior of the material within the body of the dam or embankment, and data foundation soils, types of the method, equivalent static stability analysis, sliding block method, dynamic analysis, simplified or rigorous, which you can use when the maximum cross section of the dam, sorry, all right, just a moment, I want to move it here. All right, when the maximum cross section of the dam stability requirements specified in type A, no future stability analysis is needed. Otherwise, the designer may proceed to the procedure described in type B. If the stability requirements are still not satisfied, the cross section of the dam or embankment and or foundation soils will require improvement. You can see type A, B, and C method here. And equivalent static stability analysis, a limit equilibrium factor of safety of 1 is usually considered acceptable in the equivalent static seismic slope stability assessment. But I prefer to recommend you 1.2 is better, because 1 a little bit maybe some errors during the construction in terms of compaction and other options. So it's better to use 1.2 for safety factor. Also, you can use equivalent static forces, forces static related to peak ground acceleration and amplification of ground motion. You can use table 1 and 2, all of them possible in this criteria to use. Also, about application of forces, soil properties is very important, since earthquake loading is rapid. Stability for an earthen or an embankment is usually considered under undrained condition. Soil properties used in analysis should reflect softening because of poor water pressure generation and strain development and cyclic strain degradation. Consolidated undrained strain parameters should ideally be obtained from simple shear testing of undistributed samples carried out in the laboratory. And you can use CPT and SPT test. And as you see here, the undrained shear strength for cohesive soils is estimated using field one shear test or other appropriated methods if the dam foundation is underlined by sensitive soils, sensitive clay soils, in fact, is undrained stability assessment, residual undrained shear strain should be used. And other notes, sliding block methods based on Newmark sliding. When you go to GeoStudio for slope stability in static or dynamic conditions, you use Newmark sliding. It's very good and simple software to try and error about slope stability, as I used mostly. And sliding block methods, definition of sliding block methods based on Hinz, Griffin, and Franklin methods you can use. What about acceptable deformation? Experience indicates that permanent displacements are limited to less than 1 meter if the ratio of yield acceleration to peak acceleration A max is at least 0.5. Large deformation may be acceptable depending on available freebird and consequences of deformation. Also, you can use Hinz, Griffin, and Franklin method for peak horizontal ground acceleration. So about dynamic analysis is recommended for important dams and embankments, failure of which may lead to high level of risk, and dams located over active fault zone. Small to intermediate size dams found to be unsafe. We simplified analysis described in closest equivalent static slope stability or sliding block method may adequate data and experience are available for undertaking some exercise. And dynamic analysis employing a nonlinear stress-strain relationship provides a rational framework for estimation of the formation of an earth dam or an embankment. So there are six steps for dynamic analysis based on SEED 1979 and FIN 1986, step 1 to 6. So I have no time because I have some slides. I prefer to go on and you can read because it's so simple. Also about hydrodynamic effects, instrumentation, inspection, and monitoring is very important for dam. All of them are important and should be do. About Inspection: an embankment or a dam should be inspected once every year and or after the occurrence of an earthquake of magnitude 5 or above with an estimated free field peak horizontal growth acceleration of 0.1 g or more at the dam site. The inspection team should include a qualified geotechnical engineer and a surveyor with adequate experience in dam safety monitoring and visual inspection. The inspection team should look for signs of distress, including appearance of cracks near dam crest or in other exposed surface, uneven settlement at the dam crest, and undulations on the downstream slope face of the dam or in the vicinity of the toe of the dam. Appearance of excessive or unusual seepage from the downstream slope. All of them should be checked. And monitoring it of instrumentation and surveying monuments should include the following: serviceability, whether the instruments are in working order and appropriate calibration, measurement of permanent deformation, measuring devices, zoom to check whether there is any unusual fluctuation of seepage rate since previous monitoring. Read on prescribed schedule and data should be carefully evaluated by a qualified engineer. A record of all inspection routines or otherwise should be maintained in prescribed format. Reports from prior inspection and monitoring activities should be available to the inspection team at site during field work. Any unusual observation should be communicated to the dam authority and to the regulatory authorities by the inspection team when those observations become available. So the final, I have some study. I have maybe 10 or 50 minutes, 10 minutes, 50 minutes. So relation between material property of foundation and dynamic settlement in the earth dam. I want to a little bit explain about this study. So there are some studies, as you can see, 10 studies in this next slide, relation between material property of foundation and dynamic settlement in the earth dam, as presented in Iran conference. Relationship between fluid of reservoir and dynamic resettlement of embankment during an earthquake conference, Singapore conference. Modal analysis of embankment with effect of deep and modulus elasticity of foundation in India. Indonesia, dominant frequency tailing embankment before dominant frequency tailing embankment interface to bridge by 3D finite element methods in Indonesia, and other studies, as you can see here. So I explained some conclusions about these studies as investigated lastly. The first one, relationship between material property of foundation and dynamic settlement in the earth dams. I focus on conclusion also here. Effect of foundation properties in the embankment on the dynamic analysis were evaluated in this study. Dynamic displacement are depends on value of elasticity modulus and increase of it in the foundation case to reduction of flexibility and increase of rigid behavior, so lead to increase horizontal and vertical dynamic displacement during the earthquake, and numerical analysis had a good agreements with literature review. Attention to improvement with reinforcement of earth dams is so great in the future. And other study is relationship between fluid of reservoir and dynamic settlement of embankment during an earthquake. So I explained abstract and model. All of them are possible in the paper, as you see in Google Scholar and ResearchGate. if you search my name, Behruz Gordon citation in Google Scholar, all of them are possible to download and read carefully, please. So I focus on conclusions also. Dynamic analysis of medium-sized embankment with saturated material properties in the dam and soft soil foundation under the earthquake of peak ground acceleration 0.65 G strong earthquake is considered displacement, shear stress, shear strain depends on alpha ratio, which is conducted in reference to the height of fluid water level in the reservoir. Comparison of result in the 5 reference points of plane strain 2D dynamic analysis indicated that there are cracks at crest and settlement in foundation when the alpha ratio reached critical value of within 0.9 to 0.95. It was found that the base ratio alpha HW over H to prevent of damages is equal to 0.80. In fact, this study related to the freeboard. So I suggested that 80% of the height dam is good and 20% is good for freeboard during the dynamic analysis. So in other study, modal analysis about frequency of embankment with effect of dip and modulus elasticity of foundation investigated. And also you can see in these slides mood shape number 1, number 2, number 3, and number 4 of one earth dam during an earthquake. You see the vibration. So what is the dominant frequency is the big questions. When you analyze what is the dominant frequency is the minimum frequency in mood shapes. When you analyze free vibration analyze, as I mentioned you previously, you are n moods. So you have n mood shapes. When you make a mesh with n moods, it means that you have n mood shapes. Which one is the dominant frequency? Mostly the first mood or second mood is the dominant frequency with the minimum frequency, because the minimum frequency leads to the high and maximum period based on earthquake engineering knowledge. So conclusion, modal analysis of the short embankment was performed by finite element and plane strain 2D to evaluate effect of modulus ratio and depth of foundation ratio on value of dominant frequency. Result indicated that value of frequency was minimum and critical for resonance in modal for all models. Dominant frequency. Increase of shape moods leads to rise of dominance frequency and modulus ratio more than 3 conducted to rigid behavior of foundation. Increase the both of ratio case to reduce maximum and minimum value of the vertical displacement in the slopes and horizontal displacement, but effects of modulus ratio was more than deep ratio. And other study, dominant frequency again for bridge connected dam. In fact, as you see, there are 2 embankment and between them is bridge, same as London Bridge. So this study is for this conference, and you can see all of the mood shapes and distribution of shear strength, shear stress displacement, vertical and horizontal is possible by ANSYS, and you can see the result. And effect of material properties for dynamic condition also investigated, and you can see all. I'm looking for one very important slide. So about Poisson ratio, when you focus on dynamic analysis, you must input correct data to software. When you input bad data to software, exactly you have bad output data to analyze. So I recommend you to very careful about Poisson ratio. Partial ratio for saturated soil is more than unsaturated soil. Please be careful about that. For example, for clay saturation here, based on the literature, partial ratio is between 0.45 to 0.49. Maximum partial ratio is 0.5. I think water has the maximum partial ratio. So please be careful about input data, exactly about elasticity modulus, tangent modulus, yield stress, friction coefficient in terms of interface and interaction effects, and also partial ratio. So you must use each of them exactly and correctly. Also about this software, I want to share information. Maybe I have just 2 minutes or 5 minutes. Seismosoft software. What is this? This is a good software related to Berkeley, California University. You can get it by academic email. Just registration by academic email. You can get the newest version of Seismosoft software. When I was a master's student 50 years ago, so I used it, the first version. It was free of pay and free of mailbox, and anyways, so I used, so it's very good software to convert displacement to velocity and velocity to acceleration, or reversely by time. In fact, you can convert displacement time to velocity time or acceleration time, and also you can change the acceleration time to velocity time and displacement time reversed. So all of them are possible to see. I'm so sorry because I have no time. You can see. So this is Bakun Earth Dam in Sarawak, as I explained you. Oh, sorry. This slide is a little, not a little, very important. What is type of settlement in Earth Dam? Static settlement and dynamic settlement. Static settlement is immediate settlement for sand soils and first and second consolidation for clay soil. And dynamic settlement is possible, but sensor instrument, shaking table, and software analysis to calculate. And failure mechanism of earth dam is also so important. Overtopping, piping, and structural failure are so important in failure mechanism of dam. Earthquake loading may trigger any of the above failure modes or their combinations. So for dynamic control, slope control is so important to supplement dynamic factors. And operational life of the dam or embankment is usually 50 to 100 years. Result study to get record of a special situation to build earth dam is essential. And first step of design earthquake should be attention to notice geotechnical study and earthquake background of the site, or to be near to the fault is great. And this slide is repeated. And literature review, as I explained you. And this slide is so important for research methodology. Literature is journal, books, and conferences, papers you can use. And so we have no time. Oh yes, that's conclusion. So before that conclusion, I want to share you just this important 1 minute. If you want to go to dynamic analysis, you need to a good chart. In fact, the first is input data for ANSYS or Abacus software. You need to soil and rock shell, soil for core and foundation. You need to elastic modulus, shear modulus, density, Poisson ratio, tangent modulus. You must get all in the soil lab. And about rock fill or as used in shell, also elasticity, shear modulus, density, Poisson ratio, tangent modulus, all of them in rock lab. Also, you must collect the time history and main records based on the site effects, in fact. And for fundamental frequency design, you must focus to seismological seismosignal software. As I explained you, it's for Berkeley, California. Also, you must focus on modeling and analysis, free vibration analysis to take out the dominant frequency. Exactly, if you want to have a spectrum acceleration analysis, you need different mood shape, as I explained 1 hour ago. You need to frequency in different moods. You need free vibration analysis. And about time history analysis, it's better to select records based on the background. Site background. So if you go to the site and you want to design the Earthen, it's better to firstly it's better to focus on the background of site in terms of earthquake firstly. When you have it, you can use these records for your structures. Also, I recommend you to select some other records because of resonance condition. Maybe it's possible at next and you can use it. And also for your validation, you can use centrifuge and shaking table tests. It's final. I have no any slides. Thank you for your attention and thank you for your making a good opportunity to share knowledge. Thank you, Alger Polytechnic University, to listen me. Thank you so much, sir. Sorry, your voice is so weak. A little bit more, please. Again, repeat. Can we use Rebel? What is that? Rebel? Can you text? Section. Where is it? Just a moment to find. Can you text me? Text. Muhammad Asif Raja. Weeble. What is that? Can you text? Can you text? Your voice is not clear for me. Sorry. How the bedrock plays an important role in distribution. Oh, very good. Bedrock, bedrock can bedrock make a main role. In fact, based on the modulus elasticity of bedrock, waves in transfer, okay, to the dam body. When you have very good and resistance, wave is very soon transfer to dam body, and there is not any damping in fact. However, for example, you have one dam, one time on bedrock, second time on soil, and after that bedrock. Okay, most of time you have the second situation because of river. So site response is the main effect in these situations. Do you know what is site effect? I explain you site effect very soon. Site effect means that there are some layers on bedrock, okay, some layers with different materials. And after that is dam. So when you have the record on bedrock, as I explained you, bedrock is same as mountain, okay, but it's under the dam, in fact, okay. When you have this situation, wave is transferred between layers. Each layers have a damping, but it's not sufficient to damp. After that, site response uh, make the make the amplification acceleration. In fact, okay. For example, if your record is 20% G on bedrock, and you have some layers, maybe triple times before the foundation of dam. The top of the foundation before the dam, maybe 3 times. But when you have bedrock and exactly your dam is on bedrock, okay, you remove this. You remove this. And it's the best. When you have earth dam on bedrock, it's the best situation because you remove the acceleration amplification because of the site response. Also, also, also material properties of rock, okay, so important. You can use Nera, Shake, and also MATLAB software for this analysis, and see the result when you change the material properties of bedrock. You can get the different waves inside the body then. So when you have hardship rock, hard rock, very hard rock, is the best way. All right, thank you. I must do off my phone. Am I right? Coming back to presentation. Okay,
Okay.
which slides?
I think you may just mute it.
Okay, Professor, I'm at your service.
Uh, respected principal of University Polytechnic, Professor Arshad Umar Sahab, the coordinator and co-coordinators of the international webinar, the esteemed resource person, Dr. Behrouz Gordon, and dear participants. A very good evening to all of you. The seminars, now webinars, conferences, workshops, etc., carry the importance of milestones in the life of any academic institution. Such programs give the opportunity of knowledge sharing between the experts. We can keep ourselves abreast of the latest know-how in the relevant field. I congratulate Mr. Muhammad Danish, Mr. Shahir Ali, Mr. Muhammad Bilal, and the moderator, Dr. Muhammad Asif Raja, for organizing this webinar on a very useful topic, that is dynamic analysis of Earthen Dam. I am highly thankful to these persons. I would also like to express my sincere thanks to the participants from across the country, like the participants from the universities like Jamia Millia Islamia, Hyderabad University, Patna University, Mewat Engineering College, Amity University, Integral University, Al Kabir Polytechnic, Water Resource Department, Andhra Pradesh, and industries, apart from the participants from Aligarh Muslim University. A number of earthen dams were built in the areas of significant seismic activity in the past. Some of them have faced earthquakes with catastrophic results. Thus, the new dam projects in such zones need to be analyzed accurately and designed to resist the earthquake loads according to local seismic hazard studies to achieve a fair level of seismic performance. An earthquake is a complicated phenomena which has to be treated as an additional load on the engineering structures. The nature of this load becomes complex due to its short period of application and rapid change of magnitude and direction with respect to time. Thus, for this reason, an insight into the dynamics of dam becomes essential to evaluate their response during earthquakes. Dr. Behrouz Gordon, an expert on the subject, has very well elaborated and explained the topic. His lecture was worth listening and has added to the knowledge of the participants. I express my deep sense of gratitude to him for sparing his valuable time to address this webinar. I am highly thankful to Professor Arshad Umar Sahab, the principal of University Polytechnic, for his continuous encouragement to conduct such academic programs. He is very kind enough to spare his useful time for the purpose. I would like to express my gratitude to all the organizers for organizing such a useful event and giving me a chance to address this august gathering. Thank you very much.
Thank you so much. Thank you all, professors and students and participants. I am at your service. If you have any question, you can connect with me by WhatsApp only. My telephone number in WhatsApp I text you. You can use. And if you are interested in this topic, you can connect me, and I can help you. It's my telephone number for WhatsApp. As I text you, all of you can connect with me anytime. Thank you so much. Thank you. Bye bye.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता।